AV Stats! Hope you guys are having a fantastic day. Today we're going to talk about a special normal distribution called the standard normal distribution. So first I'm going to show you what the standard normal distribution is. Super simple. It is a normal distribution. So it has, the area under the curve is 1, and it follows the empirical rule of 68, 95, 99.7. So it is normal, okay, but it's special because it has a mean of 0 and standard deviation of 1. So this is what it looks like. Okay, standard deviation of 1, mean of 0, and so the distance between the mean and 1 standard deviation is it's really nicely laid out for you because it is very clear that, hey, this is 1 standard deviation away, and the numbers are 1, 2, 3, and 4. So the other nice thing is that really on this x-axis here, the 0 and the 1 and the 2, that corresponds to the number, basically the number of standard deviations away from the mean a certain x value is. So, if your x value is 1.5, right, this particular value is 1.5 standard deviations away from the mean. So it's just really simple. And the nice thing is that any normal distribution with any mean and any standard deviation can be transformed into a standard normal curve. And so the area within, between two values can be found pretty simply because the area under the curve of the standard normal distribution is pretty easy to find. We have like a nice little table that helps us through those calculations. So that's what we're going to do today. Yay! So say, for example, we found data, all of the heights of students in my class, in my stats class. And we want to know the approximate percent of students who are taller than 65 centimeters. Now, if it says, we're normally distributed, approximately normally distributed, mean of 68, and a standard deviation of 3. So that curve looks like this. You've got your normal curve, and your mean is 68, and your standard deviation is 3. And so the nice thing with this particular question is that 65 is exactly 1 standard deviation below the mean. So here's 68 right here, and then exactly 1 standard deviation below that is 65. And we want to know the percent of people who are taller than that. So we're basically finding the area under the curve that's above 65. And because of the empirical rule, we can figure that out, right? Because we know we've got 65% of the data within 1 standard deviation, 95 within 2 standard deviations, 99.7 within 3. So you can easily figure out, also the other thing that we know is that, the top half is 50% of the data. So that's 50%. And then this little section here is 1 standard deviation away. And since that center set of the data is 68% of the data, that means that this half is 34% of the data. So we know above 65, there's approximately 50 plus 34. That would be 84% of the data, which means 84% of the class is taller than 65 inches, okay, or centimeters, sorry. Okay, that's definitely supposed to be inches, side note. Centimeters, that's way too tiny. Inches. So, in number 2, it's a little bit different because in number 1, we were exactly 1 standard deviation below the mean. So it was easy to calculate using the empirical rule. But with number 2, it's a little bit more difficult since you're not exactly an exact standard deviation away from the mean. So that's why we have the standard normal curve, because it will help us figure this out. So the cool thing is that if we can take that data point, that 67, and transform it to be on the standard curve, then we can use basically a calculator that calculates the area under the standard curve. So for example, right, the 67, that's going to be as a z-score, so the standard curve, which has the mean of 0 and standard deviation of 1, right? Basically, this entire x-axis is all of the z-scores for a set of data, okay? And so if I have a data point like that 67, and I say, okay, what's the z-score for that 67? Well, 67 minus the mean, which is 68, divided by the standard deviation, which is 3, right? And so I get negative 1 over 3. So my z-score for that particular value is 1/3, or negative 1/3. So negative 0.333. Okay. And so what I can do is I can actually go to the standard curve, find negative 3.333. Okay. So that's going to be about here-ish on the x-axis. So there's negative 0.3. And then you can actually find the area either below that curve or above that curve or above that point. So as long as you transform it to the standard normal curve, finding the area is pretty easy. So here's kind of the how to find that area. All right, so you're going to need your packet and your calculator. Okay, so you have a packet, your AP Stats packet, with all the formula sheets and everything, and there is a table A. Okay, and table A is it's kind of like a list of all the areas, all the possible combinations of areas that you could possibly have on the standard normal curve. So I'm going to show you what that looks like. So if you can take out your packet, pull that out so you can take a look at it, look at table A. So here's basically the same thing that you have, which up here, notice that there's a Z, okay? That Z means, hey, this is the row of z-scores and the column of z-scores, okay? So if my z-score is, happens to be 0.125 or something, I can go down to the 0.1, and then I go over to 0.125. Okay, there's no 25. It only goes to the hundredths value, so we'd round this to 0.13 is what we'd round that to. Sorry for the messy numbers here, but 0.13. Okay, so then we go over to where it matches with 0.03. So this value, 0.5517, is actually the area below your z-score of 0.13. So here's 0.13 approximately, 0.13. Okay, and this 0.5517 is actually the area less than or equal to that 0.13 z-score. So that basically has found all of this area. Okay. So what's nice about that is then, if I need the area above the curve, then I just, the area under any density curve is 1. So to find the area above 0.13, I just do 1 minus 0.5517. Okay, so it'll take a little getting used to, but it's really not that bad. So all of these numbers here are the area under the curve. Okay, and then the top row. Sorry, this is so messy because I'm doing it on my computer, not my iPad right now. These find you your z-score. Okay, so back to our example from before, okay, when we want to find the area above who are taller than 67 centimeters, or 67 inches, right? I convert that to a z-score, and we found that was negative. Our z-score for 67 was negative 0.33 repeated. Okay. So then I can go to my table A and find negative 0.33. So here's my table. So there's a negative side and a positive side. We have a negative z-score. So I'm going to go find negative 0.3 is down here. And then I go over to negative 0.33, okay, where they intersect. And so the area below our z-score of negative 0.33 is 0.307, or 3707. Okay, so that is the area below the values, 0.3707. Okay, so what that's referring to is this green area here. Okay, so that's 0.3707, which means that the area that we really care about is 1 minus that. So our area is 1 minus the 0.37. So the percent of students in my class, approximately, who are taller than 67 inches, 63%, approximately 63% of my students are taller than 67 inches. Okay, so go ahead, try these next couple examples on your own. Find the proportion of observations from the standard normal curve that are between negative 1.25 and 0.81. So that's just going straight to the standard normal curve. You don't even have to find the z-score, because those are the z-scores. And then number 2 is a different question. So it's asking 20% of the observations are above what value. So it's kind of looking for, on a standard normal curve, what value has 20% of the observations above it, 20%. So it's asking, what is that value? Okay. So go ahead, try those with the table A. Good luck. So for number 1, we want to find the area under the curve between negative 1.25 and positive 0.81. And so we want to go to our z table. And conceptually, what you want to be looking for is, because the z table only finds the area below a certain z-score, so that would be from negative 0.125 to the left, or 0.81 and to the left. And so in order to find that area in the middle, we're going to have to find the area below. So I'm going to use my notation here. So the probability that z is less than 0.81. Okay, so that would be the 0.81 or less. I want that area minus this little green area in here. Okay, so that would be minus the probability that z is less than negative 1.25. And you just use your table to figure that out. So the probability that z is less than 0.81, you go over to your z table, you go to negative 0.8 and then negative 0.81. So that area is like 0.79. And then the area below negative 1.25, you got to go to the negative side of the z table. And then I want to find negative 1.25. So here's negative 1.2, and then I'm going to go over to where it intersects with negative 1.2 and 0.05, so 0.1056. So for number 1, we have 0.7910 minus 1.056, and that should be the area in between negative 1.2 and 0.81. Okay, so for number 2, we want to find this particular x value. This one you need to actually look at the table and find approximately the right area that you want. And so the problem is, on the table, it finds the area below your values. So you're actually going to be looking for an area of 80% or 0.8, because that will get you the correct x value. So you pull up your z-score table again,
Okay, so you want to look for the area under the curve to be around 0.8. So you kind of look through the numbers, 0.77346494. Okay, these are increasing, right? So you just kind of look around and check the closest value to 0.8. So it's somewhere between here and here. So we know that is 0.8, and that's between 0.84 and 0.85. So your question mark value is somewhere between 0.84 and 0.85. So what I like to do is I say, okay, what's between 0.84 and 0.85? Oh, 0.845. That sounds great. So, this is all approximate, so that's cool. So 0.845 is that value, 0.845 approximately. Okay. All right. So now I want to go through how to do it in your calculator. So depending on your preference, you can use the calculator or the z-table, but it's important to show your work. And so even if you're plugging stuff into your calculator, you still need to draw, sketch a little graph like these, the little bell curve, and show the mean and the standard deviation and the area that you're shading, in the area that you want to find. What the heck is up with this thing? It just keeps like magically moving. I like keep moving it, and then it just like ghost moves. Oh my god, I'm so annoyed with technology. Okay, so anyways, so on your calculator, let's take a look and see how you do it. Okay, so get your calculator out because it'll help if you actually do it with me. But you're gonna want to go to see the little blue button, the little blue distur above vars. That's distribution, okay, and we're doing a normal distribution. So we go, second vars for distribution, and we have these two options. We have normal PDF and normal CDF. You're never going to use normal PDF. Okay, never say never. You are probably 99.9% chance of never using normal PDF. Basically what this does is it tells you the height of the curve at the x value you plug in. So basically, if I were to give you, a normal curve and say, oh, 0.8, you plug in 0.845 or whatever, it actually gives you the height on the y-axis for that value, which is not something we actually care about too often. So don't overuse PDF. What we want is CDF, okay, because what that is a cumulative distribution. Okay, and so what that does is it's like cumulative, so it like counts all the way up to and including the value that you're observing. And so, say I want to do the problem that we just did, but on our calculator. So I do normal CDF, and you want to have your lower bound be, either a really, let's see, we were doing, we were curious to know the area under the curve between negative 1.25 and 0.81. So my lower bound would be negative 1.25. My upper bound would be 0.81. Okay, so we can plug that in. So negative 1.25. And my upper bound is 0.8. And I need to fill in what my mean is and my standard deviation. If you don't fill those in, it's going to assume the standard normal curve. So mean of 0 and sigma of 1. But see, it moved again. Oh my god. Okay, anyways. So the mean is going to be, whatever. If you have a different distribution that's not the standard normal curve, you can use whatever mean and standard deviation you have, which is nice. Because if you don't have the calculator, then you have to convert all of the values into z-scores. Not all of the values, the one that you're curious about. Okay, anyways. We'll talk about that more later. So in this case, our mean is 0, standard deviation is 1. Hit paste. If you have an 83, this is what your input's going to look like. It's your lower bound, comma, your upper bound, comma, 0, comma, 1. Okay, so that's lower bound, upper bound, mean, standard deviation. That's the order. It sucks, kinda, if you don't have in an 84 or above, because you kind of have to like memorize this, but there is actually a program that you can download to your calculator that will allow you to do that. So if you have an 83 and you need that program called Catalog Help, let me know, and then I can show it to you, and okay. So anyways, so you hit enter, and then it says 0.68249, okay? Then we go back and look at our value. Hey, look at that, 0.6854. We were close, 0.68249. Okay, so again, this is all approximate. A density curve is an approximation anyways, so it's all approximate, but that's pretty good. Okay, so yay calculators. See, I tell you, they do everything for you. Love it. Calculators are great, but remember, you cannot write your calculator speak as showing work. You have to actually show what you're doing. So draw the curve, shade the area, include the mean and the standard deviation, okay? Do not use calculator speak. No calculator talk when you're showing your work. Okay, anyways, moving on. So use table A or your calculator, whichever one you prefer. Actually, I'd love it if you tried it with both, and so you can figure out which one you like. But anyways, go ahead, try these. I'm not going to explain how to do them. I'm just going to give you the answers. So I'd say pause it, try it, and then check your work. Okay, make sure you understand that, because we're going to use this pretty much from here on out. So it's important. Okay, so 1 through 3, it keeps moving. 1 through 3 should be 0.9177, 0.9842, 0.6771, and these are the areas that you're finding. But now I would like to show you how to answer questions like 4 and 5, but on your calculator. Couple little details that I don't know if I've explained to you yet. So I just want to let you know, in terms of calculator stuff, if you want to type in infinity, for example, for some reason, like you're trying to find, for example, here, your lower bound would be negative 2.15, but your upper bound would be like really, 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 really big number, like infinity. So if you want, you can just type in like a really, really, really large number. There's another way to type it in, but it's actually more work. So just type in like 9999999 or negative 9999 for your negative value, just as long as it's a big negative number or a big positive number. So to do number 4 and 5 on your calculator, so you can do it in your on your packet, okay, with table A, or you can do it in your calculator. I'm going to show you how to do that real quick. So it's in the same place as your normal CDF. So you go in and you go second distribution, and you go to inverse norm. So that's number 3. And basically what that does is it says, hey, what's the area less than or equal to, or basically like the percentile. Hey, what's the percentile? The area under the curve that you want. And so in problem 4, we want the 20th percentile, which means we want the area below our value to be 0.2. So we put in 0.2 as our area, and we want it on the standard normal curve, mean and standard deviation, paste, hit enter, and you get negative 0.8416. Okay, so the answer to number 4 is that. And then for number 5, 45% of all observations are greater than Z. That one you're going to have to plug in the area that's less than Z, which is 0.55 for 55%. So you go in, you type in the same stuff, second vars, inverse norm, and I want my area to be 0.55, and then I paste it. Again, if you have an 83, this is what the input's going to look like. You need that comma in there, otherwise you will have errors. And then your value is 0.1257. 6.6. And then you have to show your work. You have to like shade in the area. So the 28th percentile is going to be here, and I want all the area here to be 20%. Shade that in, and then 45% of all observations are greater than z, so that's going to be approximately here, and that's the area where 45% of the data lies above whatever your z value is here. Okay, so that's it. Sorry, that was kind of a long video. It's hard with stats because there's a lot to explain. So I'm going to try to keep them as short as I can. But if you're a really fast learner, you can watch it at double speed. Okay, bye.